Modern society has so many devices and things which are connected together via wireless. In wireless communications, we have a transmitting and receiving antenna, and the space between them is open for anybody to eavesdrop on or transmit interfering signals. So this becomes an attack surface. And seeing that all the signals are radio frequency derived, we tend to call this the RF open attack surface.
These attacks could attack everyday personal communications such as laptops, mobile phones, even car keys. But more seriously, it could affect industrial applications such as robotics, warehouses, and even power plants.
SWAN Prosperity Partnership is funded by the UK government, and it is addressing secure wireless agile networks with our partners GCHQ, Toshiba Europe Limited and Roke Manor.
GCHQ cares about making the UK a safe place to live and to do business. We're constantly scanning for potential future threats or items of technology that could be made more robust and digitally secure. We throw our weight behind initiatives which help our corporate agenda.
Toshiba is the lead industrial partner in this partnership, and we are working together with the university and other industrial partners to really leverage their skills so we can turn research and development work into product.
Roke's a technology R&D and consultancy company, and we work across a whole range of different technology areas, and many of those are applicable to SWAN. We've got a lot of work in sensors and communications, so RF, but also cybersecurity and information assurance, which is the secure part of SWAN. We've also got a strong data science, AI and machine learning capability.
One thing we can do is build receivers which are more robust against jamming, or we employ an interference technique to actually cancel the jamming signal away from the receiver. We also need frequency agility, and here we're developing a technique known as a digital RF power amplifier.
A power amplifier is essentially one of the most important part of any transmitter architectures. It's important to research these systems because they are vulnerable to attack. We've identified a number of vulnerabilities, and also we want to future-proof systems for these potential attacks in the future.
We have many projects involving wireless technology, for instance with South Gloucestershire Council, where we have developed one of the largest Internet of Things testbed in a project called Umbrella.
This is an umbrella node. It is a multi-radio and multi-sensor device. It allows to use different network and radio technologies, and then we can deploy our SWAN security solution on this device. It is very difficult to access real deployment, so thanks to this partnership we have the possibility to deploy over a very large scale network, a real network.
With cybersecurity, it's very important to detect, are you being attacked, or has somebody put a rogue sensor in your network? So we've developed a technique to fingerprint a set of trusted devices. So if anybody was to introduce an additional device which was unknown to us, we can detect the different signature.
Often we're working with legacy technology that hasn't been designed in an era of modern threats. So SWAN is a way of actually addressing that and starting to do what we call secure by design. So it's looking at new architectures that are inherently secure.
Future engineers have got to understand about security, and at the university we're bringing that into our education syllabus of our undergraduate students.
So this year I proposed 4 undergraduate final year projects based on Raspberry Pi to implement machine learning technologies to help our system to be more secure and safe.
The future of engineering in this space is going to be about collaboration. The government has the understanding of the operational problems that they face. In industry, we bring applied engineering. We bring the ability to accelerate the delivery, to bridge that gap. And of course, academia brings the real cutting edge research. And so all three together actually bring a different perspective and a uniqueness to the problem that when you make work effectively, you get a much better solution much more quickly.
If we're successful in tackling these threats of the RF open attack surface, we remain 1 or 2 steps ahead of those who want to thwart our style of life and our connected devices.
Being vigilant is crucial for maintaining correct working systems and hopefully the prosperity of the country. Where there's centres of excellence, we act as a catalyst to actually bring those together for the greater good. Initiatives like SWAN are a really good example of something which is actually working towards that wider aim.